So I'm going to talk about microservices and Docker at scale in the enterprise. I'll talk a little bit about sort of what it is I am and I'm not talking about. If you're hoping to walk out of here being a microservices and container guru with a Kubernetes, black belt, that's not really what I'm going to talk about today. It'll be a little bit more sort of general than that and talk a little bit about best practices and challenges and those kinds of things. So who here right now in their organization uses containers? Those of you that have your hands up, leave your hand up if you're using them in production. That's still pretty good. That's growing, which is good to see. How about microservices? Good too. Great. So what I'm going to talk about, just quickly, kind of microservices, what's cool about them, containers, what's cool about them. Why do we always seem to talk about containers and microservices in the same sentence? Why are these sort of the PB&J of architectures, and that's a very American-centric kind of thing to say, but peanut butter and jelly go well together in a sandwich, at least if you're American. A lot of other cultures would find it really weird. I'm Swedish, so I can say that. And talk a little bit about what are the challenges to good outcomes using these things. Both kind of challenges that apply to both of them and also individual challenges for each thing if you kind of choose to go off and use them on your own. And what are some of the extra challenges that we face when we're doing this kind of at enterprise scale? And I should be sort of clear, when I'm using the word scale here, I'm not necessarily just kind of talking about how do I deploy a gazillion nodes into Kubernetes so that I can handle, a bazillion events per hour kind of stuff. I'm really talking more about we're a large enterprise. We've got tons of different technologies that we use. We have tons of different applications that we support. Some are legacy, some are greenfield, some are evolving, some are pickled. Some have auditability requirements, some don't, all that kind of stuff. And then talk a little bit about best practices to kind of overcome some of these challenges. And I'm gonna just be sort of straight up front here, which is I'm not the world's expert on either one of these subjects. There's probably people in this room who know far more about this stuff than I do. So if you disagree with something that I say, please correct me, or please, if you have insightful ideas, let me know. I probably might regret saying that, but there you go. So what I'm not going to talk about, or what I'm not going to sort of imply or spend time on, microservices are not for everyone. It's not for every application. It's not for every environment. It's not for every organization. It is not the one-size-fits-all tool that will, save your marriage and make your daughter love you again. That's not going to happen. Well, I mean, she might still love you, but not because of microservices. I'm not going to tell you that if you can't containerize your app, it's crap. There are some things that are very suited for containerization and some things that are more challenging. Not going to talk about, how do we get around this thing, with one line of Haskell and, boom, we're on our way, kind of digging deep, or, compare Kubernetes to data center, any of these other things. I'm not going to dig very much into these things. But why microservices, right? I think, speed to market is obviously something that's very much on the forefront. And if you look at any of the kind of KPIs that we use in the DevOps community, speed, lead time, time to recovery, cycle times are all very important. One of the nice things about microservices is it allows you to divide and conquer a technical problem, right? Split it into loosely coupled services and use whatever tooling is appropriate for the problem that particular service is using, so you're not kind of locked into sort of a monolithic tool set, which is good. You can scale these services independently. You don't have to scale everything just to scale one piece, which is kind of a big deal. And they can have a life cycle independent of the other services. So they can have their own team, their own pipeline, do their own releases, all of those kinds of things. Lots of goodness to be had there. That kind of stuff allows you to scale teams and scale applications better. You can't quite get past the mythical man-month sort of scenario, but you can cheat it a little bit, which I think is pretty cool. Smaller teams, smaller autonomous teams tend to be more productive. We've kind of known that for a long time. Microservices allows you to kind of take a large problem and decompose it into something where smaller teams can work on it. And then from a resource utilization point of view, I'd rather have lots of small fit-for-purpose services running on hardware, utilizing it the way it's meant to be run, than to have sort of my monolith with, a bunch of different pseudo services inside, only one of which is really active on this node, and the rest are just kind of sitting there consuming memory and not really doing us any good. So it lends itself to better resource utilization. So containers, and we'll start to sort of see a little bit of a theme here in terms of how these different things play together. Containers, well-defined, isolated runtime environment for typically a single process, right? X as code, whether it's platform or infrastructure or whatever you want to call it. Write your Docker file, build your Docker images, put them in a repository, share them, right? Again, right, you kind of isolate the tool chain and the dependencies into the container, so that instead of shipping your artifact plus your 2 megabyte README that explains the 42 different environment variables that you have to set, which you also have to have admin privileges to do in order to launch the application successfully, you package that all into a Docker file and sort of build the image, and magically, you're able to distribute that thing without the pain that comes along with firing it up. Docker run, go, done. Then there's sort of an environment consistency issue that gets addressed here, right? Or that freaks people out depending on which side of the coin you're looking at it, right? I am shipping you, essentially an image that has everything you need to run this one process. Whatever libraries it needs, whatever tool chain it needs, whatever dependencies it has, all of those kinds of things. And so if I move that environment through my software pipeline, I'm much more likely to end up in production with an environment that looks just like I had in dev, right? It might be larger scale, it might be running in another data center, not on premise or on my laptop, what have you. But they're going to look a lot closer together than if we sort of have our kind of usual snowflakey environment management that a lot of us still stick to. And like I said, you move the container through the pipeline, not necessarily just the artifact. And then one of the big selling points of containers, in addition to this sort of isolation and dependency provisioning, is just the low overhead of running a container process, right? Instead of having to fire up a brand new OS just to run that one process, and I'll explain in the next slide why that's sort of an important thing. You fire up the process in an existing OS instance, you share a lot of the same things. A lot of the things are provided by the core OS, by the core kernel. So again, you can scale up and down a lot faster. These processes, these containers start and stop a heck of a lot faster than VMs do. Better utilization of the hardware, again, because you don't have n copies of an OS running on your virtual machines taking up space. And of course, there are these groovy kind of container hosting services out there, lots of them that provide you with the really cool auto scaling parameters that you can do, scale up, scale down, provide good monitoring. I'll talk a little bit about that. Give you a lot of the resilience that you need in terms of bringing things back up when they go down, all of those kinds of things. Now, is there the one API that they all support to do this? No. They're all kind of different right now. There are some initiatives obviously underway to kind of standardize some of this stuff, but it's a little bit of the Wild West still, and we're moving fast. And some of these tools do provide some orchestration, but they tend to be kind of container-only orchestration, which becomes relevant for the enterprise, because most enterprises are not going to be dealing with kind of a greenfield container-only world. There's going to be legacy applications, regular multi-tier applications, hybrid applications, kind of all of that to deal with. So why microservices and containers? Well, if we think back to sort of 2002, back when dual core boxes are out. Cool, I have twice as many CPUs as I used to. But it used to be that if you wanted to deploy a microservices architecture, if you even called it that then, it would be one service per box, one service per physical box. 1 or 2 core box, and you rack a bunch of them up, and yeah, maybe you could buy some expensive hardware and run your service on that. But if it's not going to take advantage of the 32 cores, somebody's going to walk up to you and say, hey, can I borrow that machine? It doesn't look very busy. So resource utilization, big waste there. Comes hypervisors, virtualization, 2007. These dates are approximate, don't hold me to them. So we can say, fine, we'll run a big VM on a big piece of hardware. We'll run multiple services inside of that VM. But then you get the, you can't run A and B together because they have a conflicting dependency. Or yeah, we did that until service C fills up /temp, and that brings down service D, so now we want to run those separately. And yeah, we tend to run service E by itself when we get past QA because of how it behaves. And you kind of notice how every sentence begins with yeah, when the point of the sentence really is no. No, don't run those things together. Run them separately. So there's this sort of tension of, I want to run these services in an isolated fashion, right? I want them to have only the dependencies they need. I want them to have only the overhead that they require. I don't want to interfere with each other. I want to be able to manage them independently, scale them up and down, replicate them independently, all of these kinds of things. So you can certainly do that, right? So let's fire up multiple VMs on these big hosts and run one service per VM. We get the isolation. That's groovy. But then you start looking at, say, the memory usage on this host, right? And of course, you've got umpteen copies of the OS in there, and every OS has its file cache and has its, paged and non-paged memory and blah, 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 and, overhead, waste, all of those kinds of things. So, comes 2013 and containers, right? And now we have a way to run multiple services with low overhead, inside of a isolated environment, where I don't have to have things like conflicts between dependencies and things like that. And that's really kind of where the PB&J part comes from, right? Microprocess, one process solves, one problem, tries to do it well, tries to do it in isolation as much as possible. Containers, my job is to provide you with an environment and all its dependencies and then run that one process and do it till I die. That's what they do. And as we'll look sort of in the challenges and best practices, there's quite a bit of overlap in terms of what you have to be good at in order to successfully use, deploy, modify, spindle, fold, mutilate microservices and containers, which is a good thing because it is difficult. So challenges. Challenges that are common to both. These are complex tools for solving complex problems. Right? Yes, you can fire up a single Docker container running, Nginx and serving some static HTML. Everybody should do that. That's kind of the hello world. But that's, those aren't the problems we're solving, right? These are not necessarily easier ways to solve these problems, right? You will benefit in the long run, and in the long run there will be less work. But there are skill sets, there are ways of working, there are processes, things like that you have to be pretty good at to be successful with these. Orchestrating the software pipeline becomes a little bit more complicated because quite frankly, if you have a monolith, you just have one big rock that you're moving along. If you split that into 50 different microservices, now all of a sudden you've got at least if you're following sort of best practices, 50 different pipelines. Maybe you don't have 50 different teams because you don't really have that many people and those kinds of things. Testing becomes more complex, right? I have to be a lot better at mocking, stubbing. I have to be a lot better at, when do I start doing integration type testing? And how do I treat my pipelines in such a way that, by the time we get down closer to production, we're confident that when I roll out, version 2 of this service, that it's not going to break, all the dependencies and all its users, those kinds of things. So there's integration testing and API contract testing and all of those things you need to worry about as well. And of course, there's increased deployment complexity. Now, some of the things get easier, right? So, if you manage to deploy your containerized app into, one of these cloud containers, and you say, hey, scale this part this way, scale this part that way, that part is, fairly easy. But there's a lot of stuff that has to happen before then, right? You got to deploy it for development, you got to deploy it for dev, you got to deploy it for, lots and lots of different uses before you get into production. And for both of them, monitoring, logging, remediation, get very important and get more difficult, right? There are just more moving parts. State management in both microservices and in containers is interesting, right? Remove the container, remove the storage. Hopefully there wasn't a log file on there that your auditors wanted to look at because it's now gone, right? So you have to have strategies and kind of policies for how to deal with that kind of stuff. Lots of different tool chains and architectures, environments for these different things. And how do you start doing updates to applications that now become kind of hybrid, right? We've got an existing legacy application. We've built an API to it, and now we built a bunch of other services around it that provide new functionality. And now we need to do a deployment of this thing. So now we have these sort of hybrid applications starting to happen where, we still have back-end RDBMSs. We may have sort of a traditional, WebSphere, JBoss, kind of application, maybe a little bit too complicated or big to shovel into one container. And then we got our microservices, and all of these things have to get, orchestrated, which is complicated. And microservices can be challenging, right? Distributed systems are hard. Microservices don't necessarily make that any easier, right? Service composition is difficult. It's expensive to change if you get it wrong. It's one of those things where a lot of people say, look, even if you're starting in a greenfield, live as a monolith for a while, right? Until you know that you understand your domain a little bit better. Now modularize, like be smart about your code and put things in different modules and so on, but you don't necessarily have to start introducing network socket connections between your code just to improve your code. Right? You can write bad or good code without microservices, right? Understand your domain before you start trying to figure out where these API boundaries should be, because that'll probably change quite a lot early on. Now you've got inter-process failure modes to deal with, and the network is not resilient, and you don't have zero latency, and you don't have infinite bandwidth, and back in your nice little monolith world, that didn't matter because it was all in-process communication for the most part. But now you're dealing with other machines and load balancers, and what happens if that one fails, and those kinds of things have to be dealt with. And one of the powerful things about microservices is sort of this notion of abstractions. But abstractions, that look good on paper, can also become performance bottlenecks. The one example I use, which is kind of totally unrelated, is DirectX from Microsoft, right? Windows 95 comes out, all of a sudden DOS game developers are pissed because they can't get to the hardware anymore, right? They have to go through this new layer, and it's slow because it's an abstraction. It's meant to abstract you from the hardware. That's a good thing, but it's slow. So out comes DirectX to sort of solve that problem, or help solve that problem of getting you a little bit closer. But the point being, abstractions are very powerful, but they can also introduce latencies and delays and complexity and those kinds of things. So you got to watch out for that. State management in microservices is a big deal, right? Where are transaction boundaries, right? If you have transaction boundaries that are going to happen across multiple services, maybe you should rethink. Do you really want to go down the road of distributed transactions and having to deal with all that kind of stuff, or can you come up with a better way of doing this? Does this need to be all one transaction, or can you break it into two with messaging in between? So that you make sure that everything happens and those kinds of things. Caching gets interesting. All of these become kind of more difficult. And then, there's this promise of, look, we'll have a team for every service. It'll be cool. Everybody works on their own service, which is great until you realize that you have 58 different services and 12 developers. Right? So you don't really have a team per service, right? That doesn't really compute anymore. And even if you do have a team per service, you got to watch out that doesn't become sort of silo per service, right? Well, I did my part, that's your problem. And then we sort of go into our old bad patterns of throwing crap over the wall and those kinds of things. And then you sort of have to keep in mind kind of Conway's law of, whatever patterns we use to communicate, that's kind of what our code's going to look like too. I'm paraphrasing that horribly, but if you have 4 different teams, you will have 4 microservices in your microservice architecture. Maybe that's not the right number. And then, more on an enterprise sort of side, but what do you do with legacy apps? I mean, am I going to rewrite them all from scratch? Probably not, unlikely. Am I going to ignore them? Yeah, I might ignore some of them. They're working, I don't need to touch them. But some of them might need to evolve. Some of them might need to get better. So there's going to be this sort of hybrid, kind of lifestyle that we all have to live for quite a while. For both of kind of containers and microservices, actually, good system comprehension is key, right? You have to know the ins and outs of the system, right? Otherwise, you can't sit down and evolve the way the services talk to each other. Some things are pretty straightforward. Yeah, we need a login service, we need an avatar, GIF service, we need a recommendation service. But after you get into the weeds a little bit, it gets a little bit more complicated. So good system comprehension is kind of key. What are all the pieces? And it's amazing, quite frankly, how many organizations out there don't know. Ops doesn't know, dev doesn't know. Ops doesn't know the kind of the model coming out of dev, and dev doesn't know what ops has to do to get it running. And so there isn't good system comprehension. And now we want to split it all up into more pieces, which is, can be a recipe for disaster. And your service might be large or small, but how large is the deployment footprint? I mean, yeah, can you fire up, WebSphere inside of a container and deploy 18 different WAR files to it? Yeah. Are you missing the point? Maybe. I don't know. Probably to be determined. More challenges. This first one here was from a tweet that somebody sent out. I think it's the honest status page. Every outage is like a murder mystery. It was Mr. Grimley, in the study with the candle holder, right? Which microservice failed, or which one failed first, right? Because likely what you're seeing is a cascaded problem, not the original problem. So now you got some monitoring and logging and analytics and all of those things are really important. Then you got dependency management to deal with, right? We revved our API for a particular service. We deprecated an old API, but we didn't realize that somebody else was still using the old deprecated API. What do we do now? Do we need to be backwards compatible in our API, or do we need to run both versions at the same time and use some sort of registry or DNS magic to kind of get that? The complexity of getting these things started, right? I mean, it's kind of comforting to fire up Jetty and drop a WAR file in and boom, I have a monolithic application, right? Now I got to start 58 different processes and I've got to figure out how they're going to talk to each other and all of those kinds of things. That can be daunting. So of course automation is a big deal. And then correlation and tracking of things through the system, right? So we get a request coming in, it gets assigned a tag, it gets logged, and then it goes to another service, which uses a completely different format for the request IDs. And so now I don't have a way to track it through the system. So monitoring tools that get inside of HTTP requests, database requests, those kinds of things, and allow you to sort of insert correlation IDs, or if you use a tool or build a tool where you kind of insert your own correlation IDs so that you can walk a request through all the various pieces that it touched in your infrastructure until it succeeded or failed is pretty important, right? Because otherwise you're just looking at a bunch of pieces on the floor with no hope of figuring out. Network issues, kind of already covered that. Containers are challenging. You got to figure out what you're going to do about state, volume, and data management, right? Oh yeah, I wrote a log file, so just go get the log file out of the container. Oh yeah, we removed that container. We don't need it anymore. Well, where's my log file? Somewhere else. The auditors wanted those logs, but they don't exist anymore. So you got to, you sort of got to deal with that. Those are sort of silly examples in a way. Security. Big deal, I think security from sort of two perspectives, right? One is, look, containers are new technology. There are going to be security holes that we don't understand or don't know about. You are kind of running, in a rooted environment, and there are some best practices you need to go through to get past those kinds of things. But also a container is kind of a black box to a lot of people, right? I mean, here's an image file, and all I can do is say Docker run. How do I know what's in there? How do I scan it? Do my tools know how to deal with containers and peek inside of them? And how do I scan an image file? And you kind of there's a bunch of new stuff you might have to learn. Monitoring. What if your environments are coming and going all the time? Monitoring tools kind of have this bias for once you tell me about a system, I'm going to keep track of that system until the end of time, right? Even if you decommission it. Right? So your dashboard's going to be red until you figure out the 892 VMs or containers that you created, set up monitoring for, and then tore down and reconfigured, and they came up as different IP addresses, and now your monitoring is kind of gone all to hell. So you got to worry about that. What hosting service should I use? Do I want to lock myself into one of those ecosystems or not? The ecosystem is moving really fast, so the decision I make today might be less relevant a month from now. And then sprawl. We're going to have container sprawl just like we have VM sprawl, and we'll have to find techniques for figuring that out. So, a minute 42 to go. I'm going to talk really fast. So, challenges at the enterprise scale. Technology maturity. I mean, enterprises like to work with mature technologies. We're getting a little bit better, I think, about being adventurous, but that's still a big deal. Forrester last year did a big survey, and security, variable performance, and how do we integrate with our existing stuff were the top 3 concerns that enterprises had. Large Fortune 20 bank, 6,000 different applications. Motivated to do containerization because of the efficiencies, ease of scaling, ease of replicating, all of those. Kind of did a big survey of what they got and figured, maybe 20% of what we have is containerizable. And the rest isn't, based on, is it on a platform that I can containerize? Does it use a tool chain that I can containerize? Are the dependencies, that work and do that? Does it have the right life cycle to support that? And I have one of everything. Of course, I've got one of every database, every this, every that. So a lot of stuff to do there. Governance and auditing can get a little bit more complicated. So you have to get good at kind of collecting all of that information. And then there's this bimodal, multimodal software delivery process happening. So big enterprises are going to have monolith applications, microservice, containerized applications, and everything in between. right? There's going to be a lot of kind of hybrid stuff going on. And even if you don't have hybrid applications, it's still kind of be nice to have one pane of glass. You can watch your software pipelines go by, no matter how hip they are or how square they are with respect to their technologies. Now I'm going to talk really fast. So best practices. It's not like this is the important part anyway. So your automated software pipeline is your friend, right? Automate, 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 automate. I'm biased because I sell those kinds of tools, but I happen to believe that that's pretty important. Ideally, you've got one platform that deals with all your different ways of delivering software, so that you don't have kind of silos of how you deal with this kind of stuff. One question I think you should ask yourself is, how's my test coverage? And are my tests automated? And when I say automated, are they really automated or just automated, right? If you don't have automated testing, microservices and containers and all this kind of stuff, don't do that until you figure out how to automate your testing, because it is going to be a nightmare of instability and weirdness if you don't have a reliable test framework where you can check in, and if everything is green at the end of that pipeline, that you have confidence that you can push to production. Get good at that before you. Now, maybe you need to get good at both, but you absolutely have to get good at the automated testing kind of thing. And then, self-service automation. If I get rid of ticketing systems, and I don't mean like Jira for bug tracking, I mean like ticketing systems where I request something to be done on my behalf, and replace them with self-service systems, right? Ticketing systems are just incredibly expensive Post-it notes, right? Because until the guy gets the notice and he's back from his 3-martini lunch and I'm kind of tired, I'm going home, I'll do it tomorrow, and then maybe he does it for you and maybe he doesn't, right? Self-service, push the button, make the environment happen, run the test, collect the results, show them, right? No human intervention should be necessary for any of this stuff. The chat ops kind of stuff that, especially that Daniel and those guys at HP have been working on and showing us the last couple of years is pretty cool, right? It helps you reduce onboarding time. It helps, reduce waiting, because people can kind of get into the mix of it and watch how things are done and how you do the self-service part. It reduces the complexity. Service discovery is a big deal. You kind of have to figure that out in a microservices world. All of these things need to talk to each other, and there's going to be a bazillion of them, and they're going to have to figure out how to configure and talk to each other. I did a bunch of talking about this sort of logging and monitoring already, so I'll skip past that. But keep in mind, that request correlation thing is a big deal, because it's difficult to debug problems if you can't watch the thing bounce through everywhere. And then if your monitoring tool is container aware and can actually monitor your container as opposed to the host that it runs in, so much the better, right? If you've got 15 containers running on one host and all you get is the CPU load for that host, not terribly useful, right? Microservices best practices. Build domain knowledge. Understand the domain before you start to make difficult decisions about where to partition the problem into different services. Avoid premature decomposition, right? Even if you're starting from scratch, you've got a completely green field, stay monolithic for a while. Keep it modular and be good. Write good code. You can write good code without microservices, right? You can also write bad code with microservices. In fact, it's probably even easier. You got to be really rigorous about failure and error handling, right? I mean, we're so used to, I make this call synchronously and it returns an answer to me, right? What if it hangs? What if it throws an exception? What if the other endpoint isn't there? All of those kinds of things you've got to deal with. Be flexible at staffing and organization, right? Because if you really want one team per service, do you have that many people? What are you going to do about that, right? There isn't necessarily going to be that sort of mapping between the things. Transaction boundaries and foreign key relationships are going to be interesting in your life as you're trying to decompose a monolith that uses an RDBMS. You may even start to look at things like, do I really need ACID for that? Do I have to use an RDBMS? Can I use a key value store instead? Can I use event systems instead of sort of RPC-like systems, and use sort of a more asynchronous method of doing this to kind of decrease coupling even more. Be conservative in what you do, be liberal in what you accept from others, Postal's law, I think. Use an independent delivery pipeline for each service, right? If you don't, then you're now at the mercy of all the other services that need to deliver as well. I was just on site with a customer last week and ran into this problem where their ask from us was, well, we have 5 applications in this release, but 2 of them aren't ready to go. So we'd like to release just the 5 and not release the 2. And my question to them was, well, if they're independently releasable, why are they in the same pipeline, right? I mean, why don't you split them up? And that, long conversation after that. It's not as simple as that sounds, but, test them, Run all your static analysis, security verifications, use your pipeline. Container best practices. Use a registry. Container native monitoring is good because just host level monitoring isn't going to tell you enough. Think a lot about where your state's going to get stored, where your data is, all of those kinds of things, and pay attention to security. Even more so than you sort of would normally do. And there are tools out there that will scan your images, do vulnerability checks, best practices checks, those kinds of things. Put those into your software pipeline, right? Make that just another phase in your pipeline, not something you do the day before release or something like that. Know what's running where and why. Understand the platform limitations that might, kind of limit you. Avoid image bloat. If you can work with immutable images or immutable systems, throw away the SSH key. Why do you need to log into that machine anymore once you've deployed it, right? Immutable servers are kind of a cool deal. And then I just couldn't resist putting up a funny picture at the end. So, I'll do that. I put the link in there too because it's not my picture. But, and that's it. I went a little bit over, so I don't know if we have time for questions or not, but thank you very much. And I'll stick around for questions in case anybody has them.